Oceans remote sensing. Oceans are the origin of life on Earth, which the first humans feared and which forced them towards technological innovation to first sail them and then dive into them. Nowadays, oceans are our close friends, a great source of food stock and a really helpful source of information about our world, teaching us about climate and natural disasters. Thanks to global observations, extreme weather events such as tropical cyclones or explosive mid-latitude storms and polar lows can now be more accurately predicted and tracked.
Challenges facing ocean remote sensing are as unlimited as the variety of sea surface dynamic and meteorological conditions across the globe and the range of spatial and time scales. The increasing quality, quantity, and duration of these ocean observations are then critically important for practical applications, as well as to assess local or global climate changes, both from natural and man-made influences.
Ocean monitoring certainly demands skills in making continuous observations and real-time interpretations in a wide range of spatial scales, from meters to hundreds of kilometers. This is why available global observations from space are an indispensable tool to analyze these large areas of the planet. With remote sensors, we can look at the oceans using different techniques, which allows us to study the ocean color. We see ocean blue because it reflects the blue color of the sky. However, if there are any suspended particles in the water, the color will slightly change. Measuring the ocean color allows us to know which kind of particles are present and their concentration, such as chlorophyll, yellow substance, and sediments in suspension. And when the water is very transparent, we can even estimate the depth of the sea and classify the different types of algae. Ocean surface. Synthetic aperture radars can provide very fine details of the ocean surface, and they can see through the clouds. They are very useful tools to detect sea surface currents or to detect targets such as ship or oil spills. Wind speed. Radar scatterometers are used to measure the wind speed and direction in the surface of the ocean. This helps us to improve our climate studies and to better understand the air-sea interaction. But when it's time to monitor hurricanes, we use microwave radiometers, a very precise tool. Ocean topography. The surface of the ocean bulges outward and inward, mimicking the topography of the ocean floor. At global scale, these bumps are indicators of currents and changes in water density associated to temperature and salinity, and can be measured by radar altimeters. Ocean salinity and temperature. Small variations in ocean surface salinity can have dramatic effects on the water cycle and ocean circulation, as salinity determines seawater density. As ocean stores more heat in the uppermost 3 meters than the entire atmosphere, its circulation is key to maintaining Earth's climate. Studying the ocean can help us to foresee upcoming natural threats, such as El Niño event, a cyclical climatic phenomenon related to the warming of the eastern equatorial Pacific. Anticipating it, we can save many lives and economic losses.